Hello. Thank you for joining today. My name's Steven, and I work at Netflix. And so Franklin Roosevelt once said, there are only two certainties in life, death and taxes. Is this a bit hot, the audio? Is it good? Today we're going to be talking about tree houses. So I was running this talk by my kids, and they said, "Daddy, that doesn't sound fun. You should talk about tree houses. That would be fun." And they were absolutely right. So we're going to talk about tree houses. This is a guide to surviving change without breaking everything, and also how to build a tree house. I love tree houses. There is something magical about a treehouse, and also immensely impractical, because you're trying to build a structure out of dead materials, and you're attaching it to a tree that is alive and growing and changing. But you want this thing to be stable because it's up in a tree. You don't want it to fall out. But also, it has to change. It has to adapt to the tree that's changing. And so GraphQL, it's actually not so dissimilar. But first, a little bit of context where I'm coming from. So I mentioned I work at Netflix. My team is the API platform team. So we provide the platform that enables the 100-plus teams at Netflix that are making daily changes to the GraphQL schema across over 800 different subgraphs that are collected together on two different federated graphs, supergraphs, if you will. And so they're making thousands of changes every month, hundreds of millions of users. And so this API platform, and the API that it exposes, it has to remain stable for our customers, maybe for you when you're trying to watch Netflix. It's a sad day when that doesn't work. And so at the same time, we're trying to innovate and change things. And the product underneath our API is this tree that keeps changing from underneath us. And so today we're going to learn about how to build a tree house, starting with the foundation, how you can design your schema from the beginning to be amenable to adaptation. We're going to talk about embracing change without breaking. And then safety first. We need guardrails and safety nets on our treehouse. And in here, we'll have a few lessons from prod, things that we had to learn the hard way. And first, I want to acknowledge, the ideas in this talk, very little is original to me. I want to thank my Netflix team, as we have learned many of these things together the hard way. GraphQL community, thank you, Andy, for let me bounce things off of you. And for my amazing wife, who's holding down the fort right now with 3 little kids, while I am with you all in Amsterdam. So, foundation, how do we design for adaptation? So what is this here? Does anybody know? It looks like a lag bolt. But it's called a tab, tree attachment bolt. And so the way this works is the bolt attaches to the tree rigidly, but then the platform of the treehouse is attached loosely. And so what this does is it allows the tree to grow and expand without bursting the treehouse off of it. Now, what happens if you don't use this? Something I have learned the hard way. Let's say you take a tree, you put a board on both sides, and you stick a lag bolt right through the middle of the tree and attach it on both sides with these boards. It sounds very sturdy, and it is for a short time until the tree starts to grow. And then it starts pushing these boards apart, and the bolts can actually pop right through the boards, because trees are very strong. So anyway, allows the tree to grow, and that's important. So how can we allow our schema to grow? Just a few basic best practices, such as naming. We know that names are important, makes our schema more usable in general, but specifically, We need to be specific with their names. And for example, let's say we have a movie type, and we think, I need to put a rating, and this is the thing I need to add today. And right now, it seems very obvious what this is, what this rating is that I'm talking about, until a little bit later, we need to add other types of ratings. That could be a user thumb rating. That's when you go like this. We started out before that with star ratings. You can do 5 stars. But there's also completely unrelated types of ratings, critics, content. Naming matters. That's all I will say about that. When in doubt, leave it out. This is also something that I think we all know, but nevertheless, it is so tempting to go ahead and add the things to our schema that we think might be needed, and your future you will thank you if you hold back and exercise restraint. Okay, now to the fun ones. We all know dry, don't repeat yourself. And so then the reaction to that is wet, write everything twice. So my colleague, Marc-Andre, coined moist. Thank you, Mark. So we'll call that mitigate the overuse of illusory shared types. So what is this? Another example from our actual schema is we added the type profile near the beginning. Now, at the time, it was obvious this is a user profile, a user being someone that is using the Netflix app to watch movies. Now, then, a bit later, we add games to the service. And games are these separate apps that you can download from the App Store. And so you have a gamer profile. And so we can add these fields into profile, but it causes conflict because the Netflix app, these don't make sense there, and so it is confusing for developers. And so really, it's better if we just go ahead and use another type. You don't need to necessarily reuse a type that's already there just because it seems like a similar thing. It's cheap to add another type, and it's really fine. It'll be okay if we just add another one. And so related to this is abstractions. Avoid unnecessary abstraction. This doesn't have a cool acronym like MOIST. It's just AU. But the idea here is that interfaces can be really powerful, but don't overuse them. And so if you have these types that have fields that happen to look similar, you might be tempted to put them under an interface, or because you're just thinking from a pure data standpoint, these things should be able to we should be able to put an interface on them. And so let's look at an example again. We have an interface on our Netflix schema that is the video type. And we have things that might appear on your Netflix homepage would be movies and videos. And so these do implement this interface. But then, once again, we decided to get into games. And we thought, is a game a video? Well, you call them video games, right? Sure, why not? A game's a video. So we made video game implement the video interface. But what's the duration of a game? I don't know. Yeah, it doesn't. It starts to break down, and really we weren't getting a lot of benefit from making it implement that in the first place. It just felt like it should, and so don't make things implement interfaces just because they feel like they should. Use them because there's a use case from your clients to abstract over these things and use the shared fields. So, All right. Now you have your perfect treehouse. You've used thoughtful naming. You have minimized the surface area. You have separate types, moist. And you have not used premature abstraction. What could possibly go wrong? You are ready to go, right? And then your product manager arrives. So about a month ago, my family moved from California to Tennessee. And my kids were like, so we can build a treehouse in our backyard now in Tennessee? I'm like, yes. And so that's why they're thinking about tree houses. So my 7-year-old brings a blueprint that she's made. She's drawn this blueprint and said, "Okay, Daddy, here's how it's going to work." I'm like, "Cool. Okay, now what's that other thing there?" She's She's like, oh, well, there's actually 2 tree houses. So there's going to be 2 tree houses, and then there's a zip line between the 2 tree houses. And then, oh, and there's a slide on one of the tree houses, but it's actually a water slide. And it goes into the pool. I'm like, there's a pool? Yeah, of course, there's going to be a pool. So your product manager is never wrong. Plans change. Your perfect schema is no longer perfect because your product is changing. And so you're going to need to evolve, even if you followed all these best practices, but we need more. So what's next? How do we embrace change without breaking? We can develop a framework for enacting our change, a workflow. And so we're going to talk about a few tools here. And the first is a directive that we've added internally that we call experimental. And what this is it's just you can put it on, say, a field that is for a cool new feature that you want to try out. Like at Netflix, we like to experiment on things. Like a lot of companies, we're trying things that 8 times out of 10, it's not going to go anywhere. But we want to try it. And so we're adding these things. And so what this is first, it acts kind of like deprecated in that this field is going to be hidden by default in introspection unless you are, you're looking for these things. And the more important thing it does is it's a signal to a client developer that this is an ephemeral field. And so you need to plan for a fallback. You need to handle the null case, but for real. It could, because this, we would like for it to be possible that this could go away at some point if it doesn't work out. But if it does work out, then it becomes stable. And now the thing is, when it's stable, this is a contract, and we have devices that are in the hands of good people that have an old iPhone and love their old generation iPhone and don't want to upgrade, and they're stuck on a frozen version of the Netflix app. And so this is going to this piece of the schema is going to live roughly forever in that app, right? But then the next step is we do want to be able to deprecate things. Maybe it turns out this cool idea that you had, not everyone likes what the AI is doing. It's doing crazy things. And so we're going to deprecate this. And so there's a few things then at this stage that we do to communicate better. And so, deprecated is just a marker in the schema. But then from that, we can connect that to actual usage and then reach out to client teams in an automated fashion to say, all right, here's these fields, and we're going to want to deprecate these this quarter. And then also dashboards that can link to for client teams and for also the subgraph owners, so you can see the status of these things. And so the basic idea here is just to connect into your company's development workflow, your communication methods, to go beyond just something that just lives in the schema as deprecated, because no one has that on their quarterly OKRs to just go through and dig and find deprecated fields. That's just not going to happen. And then it comes time for this experiment finally to die. Maybe it's something that it's been deprecated for a while and we want it to go away. And so this is a newer concept that we're trying out called a tombstone. And basically what this allows you to do is to mark something as deleted without completely deleting it. And now, why would you want to do that? Well, maybe your developers did not code as defensively as you would have liked, and this field going away would be a problem, or they did. But the thing is, the query that this was a part of, it has a whole bunch of other stuff in it. And so this query, if you delete that field, is going to fail validation. And so your GraphQL server is going to reject the entire request. And so what this means is, I guess we just can't ever delete anything, right? And that's what we're trying to solve here. And so Tombstone marks for deletion, and also you can optionally return something besides null that you want to return. And the use case that came up recently that prompted implementing this, but they wanted to return an empty list, for example, because null they found out was actually going to break the client if this returned null. And so they wanted to be able to return an empty list. And also, they wanted to be able to actually delete the server, the service and the code that was behind this, because we do microservices. And so just getting rid of the resolver isn't enough. They want that whole server to go away. And so this then can be handled at the gateway just to return the static value. Now, one caveat. So the experimental that I mentioned, that's something we've been doing internally since 2019. This is brand new. So I haven't actually rolled this out to prod yet. So talk to me in a year. I'll let you know how it went. Maybe it's a terrible idea, but I think it's a good idea. So there we go. Conference-driven development. Now we're going to play a game. Is it breaking? So I was going down the rabbit hole, breaking changes, and this is where I was talking with Andy Merrick here about what even is a breaking change. And so I went deeper down this rabbit hole. I just wanted to share that rabbit hole with all you. So here we go. We're going to start easy. Before, we made a field watermelon, and then we thought, oh darn, we have a typo. We're going to fix it, no problem. Is this breaking? Now, so if you think it is, say yeah. And if you think it's not, say nay. All right? Yeah? Nay? All right. All right. OK, you got it. Now you know Dutch. OK. So now round two. We're going to change the type on a field. So next lunar eclipse, it was a string. By the way, did anyone see the lunar eclipse last night? That was so cool. I did not know that was going to happen. Anyway, and then we're changing it to a date time. So is this breaking or not? Yeah? Nay? Oh, both? Maybe? Oh. So it's returning in the response still as a string, but we have specified the type of the string. So the response, we'll say it's the exact same response that's coming back. OK, I think we need a definition, a better definition of breaking change. Let's look at the GraphQL spec. Any change that can cause a previously valid request to become invalid is considered a breaking change. So in this case, you have a valid request. Is that request still valid? Depends. Yeah? If it's a variable? So I'm going to say this is not breaking according to that definition, because the query is going to validate probably, mostly. So there we go. Round three. You have a non-null type and you make it nullable. Is this breaking? Yeah? Nay? So if you have a query that includes the sandwich field, is that query still valid when you've made it non-null? It's still valid, isn't it? Yeah. So we'll call this dangerous. It's definitely not breaking. And that's what we do in a lot of linters. We have categories of breaking and dangerous. It means, it's not breaking, but it might break prod, so that's also bad. Now, OK, let's do another one. This one's pretty fun. So we have a type. We're once again changing the type. So it was concrete. We have a dog. Now we're replacing that with animal. But dog is an animal. Happens to be the only animal we have right now. And it only has one field name. Is it breaking? Yeah? Nay? It's still valid, right? Like you still get the dog still named Kiki, still barks, same dog. Yeah. So we'll say it's not breaking, but there is a sense though that it feels weird, right? To say that it's not breaking. Yeah. So if your client is generating its types, probably, right? Is that going to break their build? Probably. Yeah, it can break your build. Now, so if you take a dependency on a library and that library breaks your build, Would you say that library just made a breaking change? Yeah. So yeah, I'll call that disruptive. A disruptive change, and that's our linter usually it just calls it change, but I mean it's kind of a type of breaking. Okay, one more. Another easy one, right? An enum. You're adding an enum value. Is that breaking? Yeah or nay? Yeah? Nay? Both. Schrodinger's enum. Well, we'll get back to that one. We'll just say nay. It's safe, right? Yeah, it's fine. It'll be fine. Okay, so yeah, we have breaking changes, we have dangerous changes, and we have disruptive changes. The first one is what we technically call breaking change, but what do we really care about? I mean, really, at least what I care about is don't break prod. We also want to keep our developers happy. That doesn't mean never break them, but it means be mindful about it, have empathy that is disruptive to their workflow. And at the same time, we need to enable evolution. And so, whether a change is technically breaking, maybe we don't care if it brings prod down, or if it makes our developers unhappy. So this requires a little bit more than good design. Now we'll talk about some safety rails. So the first is pretty straightforward. There are even open source tools that can detect breaking changes. We have an internal one that we're constantly iterating on discovering new little interesting nuances. So that's helpful. That's a safety rail. And then you have usage metrics so that you can see what things are actually being used. Because go back to that first example, watermelon. Okay, we changed the field name. That's the obvious breaking example, right? But what if we just rolled that out and no one's using it yet? Is that breaking in any meaningful sense? Not really. It's fine, even though it's actually breaking. And so that's why you really need to know, in production, are things actually being used? So quick story. Blah, 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 and then we got paged. I don't remember if it was 2 a.m., I don't know. But the gist was a change was rolled back, a field was deleted, but the developer said, well, I checked the usage dashboard, this wasn't being used. But prod still broke. So, what went wrong? In this case, well, the usage metrics had been checked, but the deployment pipeline then that carried the change of deleting the field, that took a few days. By the time that went out to prod, new client version had rolled out that did use the field, and so then that goes live, and boom, everything explodes, prod goes down. So dashboards aren't enough. The metrics need to be included with your system as guardrails. And now in this example, in any incident that involves human error, you blame the human, right? That's, obviously the problem here is the human. No. In our systems, we have human components. Humans be humans, and we are going to make mistakes. The problem is your system that doesn't have the guardrails it needs to accommodate us flawed humans. So that's why requiring still this human step of looking at the dashboard and then getting the timing rate right, it's not enough. Your deployment process and your schema validation should take this into account. So now when you do that validation step that happens before a schema goes live, you see the usage right there. And so usage-aware validation, a guardrail that can help you. So we're talking about breaking changes. Now, one thing that we didn't mention is what about if you're doing federation? So at Netflix, we like pain and distributed systems. And so we have lots of subgraphs, and so the gateway is a separate service from the subgraphs, right? And so what this means is you have basically two contracts. Your schema is first and foremost a contract between the client and your server, right? In this case, between the client and the gateway. And then also, it defines a contract between your gateway and your subgraph servers. So what does this mean when it comes to breaking changes? Well, let's look at deployment workflow. A pretty common workflow is a subgraph. When it starts its deployment process, it validates any schema changes it has. And then, assuming that passes, it begins this blue-green rollout process. Now, the gateway, during this rollout, still has the old schema. But then, the subgraph completes deployment. And then, once the rollout has completed, then the subgraph can register the schema, which implies read validation. And that is when the gateway adopts the new version of the schema. So remember the enum example, adding an enum. Is it safe? So if you're in a federated environment and you add an enum, is it safe? Ja? Nay? Maybe? It depends. So in this case, this true story, subgraph did this, also started immediately returning new value. It wasn't actually fish. But the subgraph starts returning new value, but the gateway doesn't have that schema update yet. The gateway doesn't know the new value, and it says this is invalid, and explodes the entire request. The fix in this case that we chose is our gateway is now lenient to responses from subgraphs. Basically, an enum is just a string as far as we're concerned, and we just pass it on, let the client deal with it. Because clients, in practice, most clients today, if you're using a client library and have code gen, is probably tolerant of this. Most clients today now, they generate like a default type for enums. But that only helps if also your gateway is lenient. And so that's the solution in this case. Really, the moral of the story is distributed systems are hard. And Federation brings up several gotchas. I had a whole bunch of examples of things where it went wrong, but really, the moral is the same. Distributed systems are hard. What do we do about it? And so that's where we get to safety nets. When all else fails. And so this next step, it's a safety net is something you don't plan to jump into. You don't want to rely on this as your only thing. But there's deployment practice that works well for us. It works well in a lot of cases. Is to do canaries. That's how we deploy code. Is we deploy a small amount of the code. And then we collect metrics, and then I've automated analysis on that to see if it's safe to roll out in general. So we can apply the same thing to our schema updates on our gateway. We can canary the schema update, just as if we were rolling out a code update, and catch the issues that we didn't anticipate. These weird little distributed federation edge cases where things you think are safe are not. And it turns out there's a lot of cases where you do have to rely on this. Okay, breaking changes. Let's say you want to add a field. Is that breaking? Nay. Okay. Now let's say you want to roll back that change and remove the field. Is that technically breaking? Yes, that's a breaking change. So in practice, you're going to have to make breaking changes. It's going to happen. And sometimes there's going to be issues with that. And so that's why you need a safety net. Now, the end result of all these things, we have, like I mentioned, we have over 100 teams that are constantly evolving the schema, thousands of schema changes. And incidents are fairly rare. But we're still learning. We set a goal, an OKR this year, to have 0 schema-related production incidents. We didn't meet that goal. But every incident is a golden opportunity to learn and to improve the system. Because as humans, we're going to forget things, but the system we can make incremental improvements and tighten down our railings and our safety nets. So you've got your foundation, we've got our change lifecycle, we've got our guardrails, we've got our safety nets. So embrace change and deploy confidently. Thank you.